This is a short video on finding angles with multiple steps. Two questions I'm using involve parallel lines. In the first question here, where I'm being asked to find the value of x, I can see a couple of things going on. One, there's a triangle here with a right angle, and there's also a set of parallel lines over here. If I look at my triangle, there isn't enough information to find x just from the triangle. I know the 90-degree angle just there, just in there, but I don't know the size of this other angle. So I'm going to need to come over to the 160 degrees and work with that. There are a couple of different options here, but I'm going to use the co-interior angle here. I know that that's 20 because these two lines have been shown to be parallel, and I can therefore conclude 160 plus 20 is 180. This is 20, and that allows me to also conclude that this over here is 20 because they are vertically opposite. In a question that was asking for formal proof, you'd have to write out details of all that. In this case, we're able to just go through and say, well, it's 180 degrees altogether, so x must be equal to 180 minus 90 minus 20, and that's 70 degrees. In the other diagram, we have two sets of parallel lines and an angle that we have to find in the middle here, that angle A, and this is made difficult because neither of these extend out. You have to make a construction in order to solve this one, and there are a lot of different constructions you can do that would solve it. You could go up on a line like this and start trying to work things out with the co-interior angles, or you could also go down there. I think the fastest way is to do neither of those and instead construct another parallel line running through the middle here. So with this parallel line, we can say that those two alternate angles are 25 degrees. These two co-interior angles here, 165 plus 15 is 180. So I've got the size of that part of the angle, and now I can see that A is actually equal to the two of those things added together. So in this case, 40 degrees.